Hi everyone, it's Nono here, and I want to welcome you one more time to the Nono.ma live stream. So this is a live stream or a time that I reserve every week to do things that have to do with creative coding, workflow automation, machine intelligence, art and design, podcasting, writing, sketching, and many other things. I haven't been doing a live stream last week, so we did the last one 2 weeks ago, but this is live stream 34. And yeah, the first thing, as always, I would really appreciate if you can tell me if you can hear me okay, if you can see me okay. And yeah, we'll get started really soon. Okay. Yeah, nice to see you, Bea, online. And yeah, so I'm gonna get started, gonna introduce a few things, and also one thing that I'm gonna start doing is like an automation or like a generation of an animation for just to share this live stream on social media. All right, so as always, the first reminder, like the video to support the channel and subscribe and click on the bell if you want to get notified when I go live next. You can join us on the community at none of them as Discord. You have the invite there, and you have a QR code up in the top right. Really nice to see you again, Soje. You're never missing one, and hopefully you'll enjoy today. All right. As I mentioned before, 2 weeks ago from today, June 3rd, we covered the first part on autoencoders. We did a hands-on coding session where I personally learned a lot, and hopefully today we're gonna do a recap and maybe even see the TSNE algorithm. TSNE, I think is commonly pronounced as TSNE. And yeah, so we saw what they are, how to use them in some way, or at least how to code them with Keras and TensorFlow. And this was an announcement of a new episode that we released at the end of May with Hector Ruiz in Magic and the Art of Illusion. And this is a reminder that you can submit questions, as always, at gettingsimple.com/ask, and I'd be really glad to answer them on the podcast. And these are questions related to the things I do and mainly to the topics that I cover on the podcast. I have to say, one listener, and will be mentioned in a future episode, listener that reached out through here and then subscribed to the Sketches newsletter, emailed me while I was in Tenerife in the Canary Islands, and we actually got to hang out together and have a chat while grabbing pizza. Separate note on that, these are the 3 latest stories on my blog, so we can actually open a new page here. So go to sketch.nono.ma. So these 3 stories talk about my experience freediving. This is something I wrote before going to Canary Islands for this course. Talks about a little device that helps you helps you learn how to compensate your ears so you don't harm your eardrum when you go down. This was a freediving course, so you go down without an oxygen bottle. You go just with breathing techniques and your lungs air. First impressions, this is a post where I talk about first impressions, first things we learned that kind of caught my attention and I think are really interesting to read. And then curiosity or interesting fact, that is how to prevent your diving mask from fogging up. These are more let's say storytelling or personal memory posts, but I hope you enjoy them. As always, you can go to the Sketches place and there's like a bunch of them already, and if you want to get more detail on some of them, they're all listed on the homepage, and if you go down you can click on visit the archive. That's at none of the Masla's archive, and they're all listed here. These are not all stories but many posts. All right, so enough for that. So we were talking about some of the things we're doing, and we're gonna come to today. Today we're gonna continue with not TensorFlow.js and Pix2Pix. This is out of date, so we stack Autoencoders, maybe TSNE and understanding. So we're going to learn a bit more about how to do autoencoders with Keras. And we're going to continue following the example that we saw from this book. I'll remind you that if you buy the book through the link here or the link on the description of the video, you'll support the channel. It's an affiliate link. And this is the materials that we covered last week that we might see today. Okay, as I mentioned, we're going to see briefly how to export. And I'm going to record a quick introduction to this video. Hi everyone, it's okay. All right, let me see. How can we do this? Okay, let's record here. Hi everyone, it's Ono here, and we're going to export a set of Keynote slides from Mac as video and also convert them to GIF. There is a built-in feature that allows you to do this now on Keynote, and we can also use FFmpeg to speed up our videos or even to create GIFs from videos exported from here. All right, so really quickly, we have a set of slides here. This is a slideshow with some animations and some content that I've created. And we can go here to the file menu directly when we have our presentation. Now we can go to the file menu and then click on export to, right? We have this menu that allows us to export to movie, animated GIF, and other formats. So we can go and click movie. We'll get this panel here, and there are options here. By default, we could leave them. So go to next slide maybe after 1 second, go to next build after 1 second. I've put here the resolution for 4K. We could put them smaller. We can choose the frames per second, the video codec, and if this is self-playing, right? This is self-playing because we haven't really done a slideshow recording. We could do a slideshow recording if we went to the play menu and record, and then we will export that at the pace that we want, which is pretty interesting. So we will click on next, and after we go to next, we'll be prompted to choose a location. So live video slides. So we click on export here, and this is creating a movie. So I'm gonna remove the ones that I've created before and move this to the side. And yeah, we'll see a movie show up here on the right. This movie right now, actually, well, this is gonna export the entire slideshow. We haven't really selected a set of slides that we want to filter by, so we'll get the entire presentation. What we're gonna do next is that we're gonna export only a few selected slides, so our range, maybe we'll go from 8 till 14 or 15, or we'll build some other things or maybe like change the order just for that export. But yeah, so let's see. So here we have our video, so we can open that. Let's see what the video looks like. It looks just like my slides, and actually you can see it's 4K. If we play it, you see the animation. It waits for a second, then goes to the next slide, waits for 1 second to go to the next one, and then waits for a second to go to the next one. Same here, same here, same here. This one waits for a second and then acts, that's the animation below. 1 second, 1 second, and yeah, so on and so forth, right? So we're getting the entire slideshow just as video here, which is good if you want to show somebody or you want to embed the animations in your presentation into a video, right? So here I have that video. Yeah, so this just goes for 50 seconds. We've exported everything, and you can see that all of the animations are embedded on the video, which is really nice. So what we're gonna do is now we're going to export to an animated GIF. I'll just select maybe from 8 to 10, right? Extra large, auto advance in 0 seconds. We can choose how many seconds we want here. So we'll put some time between slides. We'll export live. And this exports really quickly. It's just 3 slides, so it won't take a lot of time. Right, so we have the GIF here, so it's looping. The resolution is not great, so the way that let me see if I can put here at 2x. Yeah, this is supposed to be the resolution at which it's exporting. And it looks good, the animations are good. But it seems that we're missing some parts of the content. So what I think, unless the GIF that you export you're happy with out of the bat, I would go to export movie. So I will set maybe go to next slide after 1 second, go to next bill after 1 second, and we'll choose here a range. So we'll say maybe from number 8 till number 15. We'll go to next. Yeah, and this is actually a bit misleading, so I can maybe maybe we can update this with the actual thumbnail. We're gonna share these to social media accounts, so we'll put this here. Yeah, we can maybe just crop this thing. Okay. Cool. All right, so that'll be it for here, and maybe we can take a screenshot here. Let me. All right, so I've taken a quick screenshot on the other screen, so we should be able to see that here. Screenshots, maybe here. All right, so we have that here. We're gonna put that on the front of our slides, right in here. All right. Cool. So now we'll go from 8 till 16. So we're gonna export. We're gonna export to movie. 1, 1, and we'll go from 8 till 16. 4K. We don't really need 4K for this, but let's just export video segment. All right. So we got that. We're gonna remove these ones. Well, we'll keep it. How big is this? 20 max. Yeah, I think we can keep that. We can save it on today's folder. So we'll go to live, make there 34, open 34, and then we'll move all of this stuff there. Cool. Cool. So now we have this new video segment that we can see in here. So let's close this, minimize this stuff. Right, so the video we've exported is this. Today. All right, so this is the animation that we've created. So if I go now to my to here, right? So I have my GIF, so it's live segment. So one thing I can do, I can just copy the name of this video or the path. And one thing I can do is speed it up, right? So I have a command here automatically that speeds up this video with FFmpeg. So this is the FFmpeg library. And yeah, you can see, for instance, this is already like that, right? It's too fast to be shared like this. So we could say here, maybe instead of 0.1, we could say 0.5. So it goes twice the speed. And I'm not gonna go in detail about how FFmpeg works in here, but that's something that if you're interested, let me know in the comments. We can record other videos on FFmpeg or ImageMagick or similar things. And for those of you who are connected online or maybe watch this offline, leave a comment on the video. Let us know how you found us, how you're connecting with us and where you're connecting from. Okay, so we have now this video, probably twice the speed. Yeah, this looks good, right? And I have a script here that will let me also extract frames and then make a GIF from those frames. So I've extracted a series of frames from this video, which, you know, these are the same image. And yeah, all right. So this is creating now a GIF, which, you know, now that I'm seeing it, it seems like a bit too big because it's 4K and we don't really need a 4K GIF. We need it something smaller. So I'm gonna, before getting the frames, I'm gonna scale this video. So I'm gonna make it 180 before scaling or speeding it up. All right, so now we have the same video at 1080, lower resolution. Let's now speed that one up. So speed up, and instead of 0.1, we'll do 0.6. Let's try that. And after that, with this video, we'll extract the frames. Again, you see, these are my new frames. Now they're lower resolution. And now we'll make a GIF. And that's gonna be here. Seems like good enough quality for and it might be too fast, I have to say. Maybe we don't need to slow down the video to speed up the video. You know, and what I'm trying to do here is just trying to do something that can be automated, something that we can reproduce later with other live stream, for example, and do that. All right, I don't know what's going on. Yeah, and you know, something that is not too efficient is that we're adding the same frames over and over for the things that are static, and we could just tell ImageMagick to just leave those frames on the GIF for longer, but you know, that seems like an optimization we're not gonna get to do today. All right, so let's do one thing. So I'm gonna get rid of this one. I'm going to start directly from the original 180. So we're gonna extract 5 frames per second instead of 10. We're gonna get the frames there. Now we're gonna make the GIF. And the GIFs are gonna be, you know, it's gonna be a bit slower. This one's actually super smooth and super sharp for the things that are there. And it's small, right? So that's something we have to have in account. It's small. And it's probably optimizing that for static things. It's doing the thing I mentioned, like actually not repeating frames. All right, so let's see what we got here. And while that's getting done, I'm going to try and export the animated GIF again from here just to see the difference in sizes. So we're gonna go to extra large, 15 frames per second. We'll go from 8 till 16, and we're going to go to next, and we'll export here. It's taking some time because we have 81 frames. I don't know, probably shouldn't take that long. And this took a lot less time. So Keynote is doing something pretty good. All right, something weird happening with this. So some of the colors are being reduced. So extra large, 8 to 16. New, add 2. All right, so this one is on. So let's see. Okay, that's finished. So that's there, that one, that one. Okay, yeah, it seems, I mean, a bit too big for what we're getting out of this. So I don't, I'm not too happy with the result. And this one is making me all red. But it's the smoothest that I think we can get. All right, so that's the first exploration. What I'm gonna do, that is gonna be the last thing that I'm gonna do, is we go to export images again from 8 to 16. We go here to high quality, maybe an image for each stage of the builds. Maybe not, so we just go for the last, and then image, so slides, right? So we export this pretty fast. We go to the desktop. So now we have our frames that are this one, that, blah, 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 right? So this is pretty straightforward. Now we have frames that we've exported directly from Keynote, and we could go now here and again create a GIF. And probably 15 frames per second is going to look crazy because those frames, each image, we need some time to look at them. Not sure what size these images are, so let me take a look. Doesn't say here. All right. But yeah, it's still the size of the GIF is still too big, I think, right? So yeah, so that's too fast. It's 2.2 megabytes. I think that's okay. So now we do GIF, and instead of 15 frames per second, we can do maybe 5 frames per second. That still might be too much. Right? Yeah, so maybe we do 3 frames per second. All right. Yeah, I think this is the cleanest. So I'm gonna do here Keynote slides 2. This add 2 allows macOS to render as if it's a Retina image, and then it shrinks it down in half, and then you get more quality when you preview it, because it basically displays smaller. So we have now these ones. All right, so what I'm going to do now is that live, I'm just going to go and share those GIFs. You're going to be able to see. So this is here, live stream. This is a document we're going to use. This is something that we can remove from here. This is something we can also remove, and we can merge this bin in here. All right, so we have a, let me see, live now. All right, so we're just gonna go here, for instance, on LinkedIn today, part 2 of stacked autoencoders with Keras, with TensorFlow and Keras. Brain, camera. All right, so Okay. Cool. And I can drag and drop this one. Oh, actually, no. So I think on LinkedIn, we need to click on add an image. All right, that's it. So we just post this. We go here. And we post this. Okay. Cool. And I don't think I'm gonna put it here. Cool. So that's that for now. And that was how to let me see what this is. Okay. Yeah, so thanks a lot for watching. This was a quick overview on how to export Keynote slides to images, videos, or GIF, and how to convert. I haven't explained how, but like we've done conversions with FFmpeg and ImageMagick from videos to frames, from videos to faster videos, and from frames to GIFs with ImageMagick. Thanks for watching, and I'll see you next time. Right, a quick outro for that video. If you like this video, go ahead and support the channel by liking this video. Okay. Go ahead and like this video if you want to support the channel, and subscribe if you want to get notified when I go live next or when I upload new videos. You can also join the community at None of the Masters Discord. And yeah, thanks so much for watching, and I'll see you next time. All right, so that's just an outro. You know how this works. And now we're going to continue. So we have our first video, which I don't know when this started, so we'll have to look at the markers later. And let's actually get going with this. I don't know how we're gonna play with this, but I intend to export some tutorials later. So let's record also an intro to this. Hi everyone, it's Nono here, and this is an overview on how we can work with autoencoders with Keras, how we can create them, how we can use TensorFlow to get features or codings from an image or a series of images, and then regenerate those images from the codings, which is also a way to create a network that can generate new images based on the information on a data set. You don't want the network to learn too many features from the images, otherwise it will just overfit and not generalize well. All right, we covered autoencoders at first touch in Live 33, so that's in June 3rd, 2021. You can go watch that live stream. Today we're gonna continue or make a recap on what we did last week. All right, so okay, so we're going to be following examples from the hands-on machine learning with scikit-learn and Keras and TensorFlow book from Aurélien Geron. And, it's chapter 17. We went through what these things are and what they might be used for, and a bit of the architecture and a bit of the code examples, right? We didn't get to use Disney last week. Maybe that's something we can get to do today. All right, let's get coding. So I'm gonna go into the Discord server, and I'm going to open the notebook that we used last week in order to continue or build upon there, and maybe record a few autoencoders that make sense in videos that that we can share, and people can watch without too many confusion, too many distractions. All right. So here we have the entire code that we used. It's a bit messy, so it's not super clean. I would like to rewrite this code, and maybe that's something that we can do. Maybe we can rewrite it in one go and try to make sense of all of this. And okay, and maybe maybe we can record a concept video. I still haven't figured out how to share screen with the iPad, so let's share iPad screen on Mac. Mirroring. All right, let's try that out. All right, so this is recess. So this is I don't know. I have a I would like to be able to add markers to the live video as we're recording and not later, so I know exactly what each part of the video is. Can you guys, let me see, when did I start the live stream? How? Okay, so I guess I can do that if I go to live 34. I can get to see how long we've been going for. So we're at minute 32. Okay, if I play. All right, 32:13. All right. Yeah, so it'd be good. I mean, Sajay, I don't know if you're still with us online or whoever is online, but a good practice would be like maybe you can put timestamps on the chat. So for instance, I'm going to do it here. So you go to today. I think here I start talking about Keynote animations. So this is minus 27. So we have like minute 6 maybe, so maybe 0600 would be like Keynote exporting Keynote slides as animations or something like that, right? So that would be 0, and 000 would be the start, and I don't know. So these are, I'm trying to think about how we could do it, or maybe even create an application that, oh, this is creating like an infinite loop there. So creating like an application to add markers as we're recording, that would be really cool. But if we cannot do it yet, that's okay. Cool. So yeah, so let's try to see how to mirror this iPad. So mirror iPad to Mac with AirPlay, maybe. I don't know. Mirror. Use your iPad second display for your Mac. Yeah, I don't want sidecar. I want mirroring. So open QuickTime, open the bar, connect your iDevice lighting USB cable. Yeah, I know how to do this one. I don't know if there is another option. Option to how to mirror with field mesh. No. Okay, let's just try here. All right. Live. Cool. All right, let me see if I can do this. If there's a way in which I could use AirPlay or something. Screen mirroring. iPad OS screen mirroring. Screen mirroring. iPad OS. Yeah, this might be for a TV. Well, I don't really know how to do this, so we're just gonna go with the easy option. And all right, so the easy option is just plugging in the iPad to the computer. I'm gonna plug the Apple Pencil to make sure that we have the Apple Pencil charged. And let's go. Where's my adapter? Okay. Let's try this out. Here. Cool. All right. Hopefully that's a bit charged. All right. Yeah, I've used previously this option, so I know, this is definitely an option. We can go to new movie recording. Right, let's actually do it. Oh, I'm here. All right, so let's actually do this also as a tutorial. Hi everyone, it's Ono here, and we're gonna see how to share your iPad screen into your Mac. First, you have to plug your USB Lightning port into your Mac, and then we'll open the QuickTime Player application, right? So you'll just open an empty app here, and we'll go to the file menu. So we'll go first to the file menu here, movie recording. You see we have audio, screen recording, we have different options. We'll go to movie recording, and then inside of movie recording, first you'll see me. This is just getting the webcam that you have set up here. But under these devices, well, actually, we should see the iPad here. We don't see the iPad here right now. Okay, so that sometimes has happened with this adapter. So I'm not sure. And let me close QuickTime first, just to make sure that's not the case. Okay, so I'm going to disconnect. What do I disconnect now? I have a feeling that this adapter might be not working properly. All right, I'm gonna disconnect. This is a bit dangerous, but I'm gonna disconnect my audio briefly. So just audio. I'll lose audio so you won't hear me. All right, you should hear me now. I don't think my so this adapter is doing anything, so I don't think it's working. Just verify, tell me if you can hear me or not. And what I'm gonna do, I'm just gonna plug this USB back on the screen just to see if it works, and I can see this has happened. All right. Cool. Right. Yeah, I don't think the timestamps will show. This is just for me to capture them, so to know at what time those things are happening. So later I can just directly put them on the video description, and when the live finishes, they will show up. Because usually that's a manual process I have to do to look for things. All right. Yeah, the audio is back. Okay, cool. All right, awesome. So now we can try this. I don't know if it'll work, but maybe. So we have my camera, and now, all right. So now we have the iPad. So you can see, you guys can see here, right? So Nono's iPad. So I'm gonna close and we're gonna start again. So let's actually just make a really quick video on that. So I'm just gonna try to produce some videos for YouTube. I haven't been posting lately. So how to share, is this share screen? Yeah, share, record your iPad stream on macOS, right? Okay, so let's do that one. Hi everyone, it's Nono here, and this is a quick video on how to share and record your iPad screen using macOS. All right, so the first thing I'm gonna do, I'm going to open QuickTime Player. So we have QuickTime Player here, and I have an iPad Pro here connected via the USB Lightning port to my computer's USB or USB-C. I have an adapter, there are many different ways in which you can connect it, but my iPad is switched on. I have an Apple Pencil. So we can go here to the top left menu on the menu bar of your Mac. We can go into new movie recording. You can also use this shortcut. We can click here, and then the first thing that happens is that you see me. So this is an input source that is taking my webcam. You can see my green screen here. And if I go into this drop-down menu, I'm going to be able to see different input sources, right? We can select the quality, we can select the microphone, and most importantly here, the camera. Your Mac will consider the iPad as one more camera. Is at the end one video input source, right? We have my FaceTime HD camera on my laptop, the Logitech Brio, this webcam that you're seeing here, OBS virtual camera, and you could have other inputs as an Elgato cam or something like that. Nono's iPad is what we want. And you can see here that we have different microphone audio sources. We can use the microphone of the iPad in case you don't have any other better microphone. In my case, I'm using loopback routing audio from my H6 recording digitally. All right, so I'm gonna click on Nono's iPad. And when I do that, you're gonna see the operation couldn't be complete. Okay, great. Let's try again. Oh, wow. Okay, it seems that we're not going to be able to do this today. Let me see again. I don't know. Something might be broken in this device. The operation couldn't be complete. All right. So I don't know what to do now because this was working on previous every time. All right. So every time I swap and my QuickTime gets my other webcam, my live stream setup breaks. All right. All right, so we have that covered there, but we don't seem to be able to do anything with this port. I'm trying to think. Anybody has any solutions? All right, I'm gonna have to disconnect my audio again, or maybe I can disconnect my webcam. I'm not sure what will be more painful. Maybe, yeah, audio is easier. So I'm gonna disconnect audio and I'll be back so you won't hear me even if I'm talking and I forget. So audio out now. We'll be back. All right. That doesn't work. I don't know. I updated to the latest iOS yesterday and something seems to not have gone okay. So I'm gonna move this to to the left. All right. So let me just merge this thing here. Cool. So that hasn't worked and I'm hesitant of continuing trying. So I think maybe what I'm gonna do now is simply try to get a, because I want to do this, so let me just try to log into a Zoom meeting and just share from there, and that's gonna be the easiest thing. So sign out. Okay, and again, just to confirm you can hear me. So all right, cool. And Okay. So we can share, only the host can share screen. Oh man. Allowed to multi-pin, hide pin. Um, yeah, I don't fully understand what goes on in here. Let me show you what's going on. So I'm gonna add here a new video capture, temporary the third screen, and we're gonna grab no. All right, so I'm going to, so you can see what I'm doing here. So I'm adding a window capture. So we're gonna see iPads sidecar window, and we're gonna grab, oh, this is window. Right, let me try window. Okay, all right, that might work. So we get Photoshop in here, and we do this is really hard. Okay, so let's do a 4K file. More or less. Okay, I don't even know what you can see. So I'm creating a new canvas here, and oh, okay, you are able to see. Yeah. So we're gonna move this into the iPad screen. All right, and we have a canvas. Cool. Okay, so here, so you can, all right, so I'm gonna get this one off. I'm gonna duplicate this scene. We'll get there. So main, left big, Photoshop. Let's just put that there. Paste this and then put this behind my camera. Will center to screen. Center to screen. You cannot see anything of what I was doing, right? So stretch to screen, fit to screen. Here we have a canvas, which is good. I hope that this is what you are seeing. So let me check. All right, yeah, so you can see this, which is good. I don't know why the screen is flickering, but it's here. And now, yeah, let me know if it flickers in black. I don't really know if this is flickering or what. And cool. It seems like now it's working a bit better. Cool. So now, and oh, and hello to Ashka and Radnia. Nice to see you around. Thanks for popping in and saying hello. All right. So this is nice at least because we have the iPad screen here. So we're going to transform this into. Let's reset the transform. All right, so this is our iPad screen, right? So first thing I'm gonna do, I'm gonna clip these things. Well, I mean, I guess that's also a thing of the screen itself, right? So if I crop that, that crops that thing there. All right, so let's reset the transform and center to screen. Okay, and now fit to screen. All right, I guess that's good or not because of the aspect ratio of the iPad. So I guess, I mean, one thing we could do if we do this is that we could increase the size to match and then center, so we'll lose a bit of the canvas, right? But we have Photoshop here, so that's great. And I don't even know where my mouse has to go. Select, boom. All right, great. We got a white canvas there, and I have the ability now to do this. Awesome. Great. This is taking me ages, guys. And I don't know how fast this is gonna go. This might slow down a bit, I think. But yeah, okay, I'm gonna focus now on the canvas. So we have this canvas that is taking me probably 20 or 30 minutes to get on screen. And there are probably a lot easier ways to do than what I had to just do. But this is what we get. This is what we get, and this is how we do. So we're gonna hide that panel. We're gonna get the brush tool. We're gonna see what layer we have. We're gonna add a new layer. We're gonna get the black color, and now we have the ability to paint. So we do that, we reset. All right. So I have here a canvas in which okay, let's just enjoy the canvas for a second. All right, so now what I want to do is go back to the autoencoders. So autoencoders, how do autoencoders work, right? So I'm going to try to explain what I learned working with autoencoders. Autoencoders, so we can write them as this. So autoencoders. They're a type of neural network. We can write them in code with TensorFlow using the Keras API, the sequential Keras API, adding different layers to a neural network with different layers. In summary, what we want to do is we want to grab an image. Oh, and now I'm seeing the problem of what we did, right? So we have a margin here that can be seen on the screen, right? So, and I'm around here, right? So where is my head? Okay. Okay. Guys, this is not easy. So it takes some time. Okay. I will continue trying, guys. Okay, so the top of the canvas is getting clipped partially. Thank you. That is something that I knew would happen and I didn't realize, but I've corrected course in time, and if I hadn't, I would have read your comment. So thanks once again, Sajid, and we're gonna have a 14 pixel stroke. All right, great. So now what I'm gonna do is explain again like a bit of what autoencoders are. So AE or autoencoders. As I mentioned before, these are networks, right? Machine learning networks that we can code using the Keras sequential API using TensorFlow and any type of machine learning library. I'm going to try to explain to you what I've learned before, and maybe out of this we get some content that gives you a hint of what these networks or this type of code might be useful for. So an autoencoder means that we have an image, right? And okay, and if we go back one step, I want to emphasize the importance of the word auto here. Auto means that whatever inputs we're feeding into the networks, right? We have a set of things that we're feeding into a neural network, right? That then will spit something. It auto-encodes, right? So we don't have to label the data. It's an unsupervised machine learning algorithm. So that's, I think, where the auto comes from, right? We don't have to do anything for the network to learn what's called the codings, right? So let's get back. So we have that auto there. What an autoencoder will try to do is get an image, right? So let's say we have an image of a landscape, the sun, and the tree. And even if it sounds a bit weird, what we want the autoencoder to do for us is go into a neural network, right? So an algorithm that takes some parameters and then outputs at the other end an output. And we actually just would like, the ideal thing would be that the autoencoder brings back the exact same image. That sounds a bit weird. I mean, to me, this sounds a bit useless. It's like I already have the image and I want a network that just returns exactly the same image as precisely as possible. All right, so there is a story here, right? This is kind of the gist of or like the overall way of seeing this. But what is actually happening is that when we have that initial image, right, for a tree with the sun, with the landscape, we put it into a network, right? This is what's called an encoder that produces, so for this image that, I don't know, maybe it's 28 by 28, or maybe it's 256 by 256, whatever amount of pixels you want, it's actually going to generate something called the codings, right? And codings are, you can think of codings as another image, maybe black and white, doesn't need to have RGB channels, that has less information, less pixels. So maybe we have a codings that are, I don't know, like maybe 5 by 5 pixels or something, right? So that would be, we have 25 digits per image. And that is sort of like a simplification, right? We have an image, and this was, let's say, 28 pixels inside. And then what we're doing is that we're making it go up to 5 by 5. So we're reducing it. So this, I don't really know the size that this image on the left could have, right? Like if we, I don't know what I've done now. This image on the right could have. So the, and again, I think I'm going over, so you're not seeing the screen. So that is a 28 by 28 pixel image. So we go here and let me see what we can see. And so you would go from something that is sort of bigger, has more detail, into something that is smaller, right? So let's zoom in into here for a second. So this image here, or this, let me just put this background as white. So we're going from 28 to 5, right? From something big to something small. And actually, you don't even need to think about the codings as something like this, right? It doesn't need to be a square by square. It can be, as we saw on a previous video on the flattened layer, it could be just a series of zeros and ones, right? That are one after the other, representing maybe like 0, 1, 0, 1, 0, 0, 0, 1, 1, 0. And each of these numbers or series of numbers that maybe has like 25 or I don't know, 30 digits, right? So let's say 30 digits. It's encoding the knowledge that the network has learned for your original image, right? All right. So going back once again to the original image, right? Or to the original concept, what we were trying to understand. Let me call my eraser here. So I'm just going to erase here, all of this stuff. So what we have here is the first part of what we're trying to learn, right? So we go from this image into an encoder, and that encoder gives us what's called a coding, right? So this is a coding, and there are a series of layers inside of here that represent the network that we're using. So let's clean this up. And again, what we have here are called codings. And after we have those codings, let's say it's sort of like compressing data, because we have now, instead of having maybe here 200 by 20, if we multiply that, so 256 by 256, that might be 65,000 pixels, or pixels, that then we'll have like 3 RGB values per pixel. Here we just have 25 digits. It's like a really, really small amount of numbers. hello, Jose Luis. So I'll take a chance to say hello to Jose Luis. I forgot to announce that we're releasing a new podcast on freediving soon, related to those blog posts that I showed before. You should check out his stuff at parametric.camp, the website, or just go to youtube.com/parametriccamp. He has awesome tutorials. Lately, he's recorded a tutorial on Grasshopper and how to do computational design, or intro to computational design in Grasshopper. Parametric modeling, intro to parametric modeling with Grasshopper. All right, so here we were talking that we go from point A, that is an image, to point B, that are our codings, right? We could save our images as the coding that we have there. And where do we go next, right? So the same way we have an encoder, we have another piece that is a decoder. What the encoder does is it grabs some piece of information and then it codes it into something that has been coded, right? The codings. And then we get those codings, we feed them into a decoder, and then we decode them into something that hopefully looks like the original image. But just to represent here, maybe we get a moon instead of a sun, and maybe we get a few branches of our tree missing, right? Because the network tries to generalize. So it tries to generalize how to generate new synthetic images from our codings. It doesn't know how to retrieve the exact original image. And if it did, it would be overfitting. It means that the network will only work for the codings that it knows about. But when it finds new codings, it wouldn't know how to generalize and synthesize another image, right? I'm going to take a chance here to make Sujay a moderator, because you spend the most time with me, I think, on these live streams. So I thought that, I thought that a few times and I didn't do it. And yeah, you can help us control the chat a bit. Okay, so yeah, we get, image A in here, then we get the codings, and then we get the decoded image. Why would you want to use this? So these networks have proven not to be effective to compress data. As I mentioned before, JPEG, for instance, is a deterministic algorithm that seems to work a lot better for this purpose. But this has proven, for instance, good to do noise removal in images, or even filling in blank parts of images. And that is because it actually reconstructs the image on the right with pretty low amount of information, the things that we get on the codings on the left. On livestream 33, we created, so we coded an encoder and we created a decoder. And if you put those together, so I'm gonna remove this diagram now. So let me go here. I don't know if I can. All right, so I'm going to get this a bit bigger. All right, so we're gonna remove this quickly. That's been recorded. All right, so how you create what's called what is this? A stacked autoencoder is by and maybe I can bring up some stuff here. Yeah, is that you would I don't know if now this is small. How can I paint here? All right, cool. So stacked autoencoder, how do you do that? So you would just join, like on a Keras sequential model. You'd put just the encoder and then the decoder. right? So our model, so the stack autoencoder would be equal to this. And you could, so normal, so Jay is asking that if a encryption mechanism have a key, and if having a key would help decoding better. um, I think we're confusing concepts here. So one thing is encoding something, like you can encode an image into JPEG or a video into MP4 with a codec, and here we can have some algorithm that tries to encode images into a series of codings. But a different process is encrypting. Encrypting means that you encrypt with a key or a password or a passphrase, as you mentioned, and then you have to decrypt it with that key. This process is meant to obfuscate the data, make it inaccessible. But what we're doing right now doesn't intend to do that, right? So there's a difference, and that's why you use a key. Still, what we use here is a machine learning model that we train. So we have to train, and that's kind of the next part. Yeah, I think, I don't know if that comment came in late, but that's kind of what I mentioned here, right? Like encrypting is trying to obfuscate the data, decrypting is getting that data back, and encoding is just trying to compress the data, or like represent it with less amount of data, or like something more representative of that data. Maybe, we can take a look at a better definition of that. So the next part here is like, what do we use the autoencoder? How do we use it, right? So we will train this network. So we have our model. So let's say that this is our model, right? This thing that we have here, and we have to train it, right? So we will be adding samples. So we'll remove this part here, and we'll be okay. So we'll get all of our images, right? So our data set, they would come through the model into the encoder, right? That has a few layers. We'll get the codings, and then we'll decode it into the other like images, right? And what we can do here, right? What we can do once we have this network, you can think this as a Keras model, is that you can train it, and then you can create a feature extractor that we did last week to get the codings. So we get the codings of each image, and then we can feed in new images that were not on the training set, and we get the codings for that image. And what I didn't get to do that I wanted to do is to then get a feature, like another network, it's not a feature extractor, that you would get this part here trained, and then you will just train it into something that you just feed in the codings, and it gives you a new image, right? So yeah, that's something that we need to do. Okay, so that's kind of a brief overview on autoencoders. So now we're gonna do some actual coding, and yeah, let's move on to the other screen. I'm really happy that we managed to sketch in here, right? So now we can play a bit with my iPad. So let's see what we have here. It's a bit weird to use Photoshop here with Sidecar instead of just natively on the iPad. So I'm prompted here. I'm prompted here to get a color. All right. This is really hard. Seriously hard. Okay. Cool. Okay, just wanted to do a smiley face. We managed to make it work. But yeah, I think there have to be some better ways to make this work. iPad, Great. Okay, let's move on to the next section. And yeah, if you guys have any questions, leave them on the comments, on the chat, or whatever you think fits. All right, let me see. Can I stop this sidecar thing? Maybe here. All right, that should disappear now. Okay, I still have Photoshop, but it's Photoshop on my computer, which is actually cool. I can move it to a different window. Cool. And now we're just gonna go to the normal screen. Okay, we're here. We're gonna leave this thing, meeting for all, take this out and shut down the iPad. All right, so there we go. We have a second section of this. I wanted to make an explanation. I think it served me to kind of refresh concepts a bit. And now we're gonna get coding. It's a bit late to start coding now, right? Not sure. Maybe we can just go through the code on the tutorial and see what happens. So Colab. Let me see what I have open here. Screen mirroring. Nope, but we have this here. All right. Great. So I have a notebook that we did last week, and I think we're just gonna go through it. So if we go and thanks Nono. Hey Namju, really nice to see you around. We need to catch up. Are you still making videos online? Like I think so. Namju is a friend from school. NG Namju Lee YouTube. I don't know if I follow your channel, but you know Namju has a lot of amazing material. NG Studio. Yeah, so just a quick shout out that you should take a look at his stuff. So he's got a lot of really nice materials on computational design, work snippet. Let's take a look at some stuff. Yeah, and I forgot how how good you are with 3D animations. Yeah, this is impressive. I'm pretty sure folks here will appreciate. NG Studio Lab. Cool. Okay, I'll post Namju's channel as well there, Jose Luis's channel there. Namju's YouTube channel and YouTube parametric cam. So this is Jose Luis's YouTube channel. Great. Awesome. Okay, so let's keep going. So we were going to set up our runtime here to GPU, which is already set, and we're gonna start running. So we're gonna get here to connect and allocate a new backend. So we have a Python 3 Google Compute Engine backend. We have 12 gigabytes of RAM and 68 gigs of disk. So you can start executing cells. So we're gonna import our dependencies here. And this is just walking through a notebook. This is not hands-on tutorial. We did that last week. So you can go to None-of-the-Mass last live 33. This is where we hand-coded all this notebook following the hands-on machine learning book. And we're gonna continue executing. I don't think when you go through notebook cells, that means that you're doing a tutorial, but I'll explain things. So we are here loading the Fashion MNIST dataset. We commented what that is. So that's Fashion MNIST is the Zalando's 28 by 28 pixel images with like 9 or 10 classes of clothing. So we get the train and validation data from here. we have here the code for our stacked encoder and stacked autoencoder. These are not really stacked. This is just the encoder and the decoder, and then we stack them, I think. And we have a sequential model. We get inputs that are 28 by 28 as we saw in that data set. We have a dense layer of 100. We have another dense layer of 30, and we get those 30 units from here, right? So the output of this block or this sequential model is our codings. And later, right, so we get the input shapes to be 30, and we have another dense layer of 100, right? So the output of this block goes to this one. We get a dense layer of 28 by 28, so we get back all the pixels for our reconstructed image, 784 pixels, and then we reshape that into a 28 by 28 image, right? So we have a stacked decoder there. As I mentioned before, the stacked autoencoder is a sequential model that just stacks both of those Keras networks that we saw above. And after we do that, we can start, compiling our model and training. We compile our model. I mean, we define this rounded accuracy metric for visualization. It's a custom metric that we provide in here, is defined as a function. And we compile our model with the binary cross entropy loss and the stochastic gradient descent optimizer. Learning rate is 1.5. We can see here that layer 0.output, right, is that 30 units dense layer. So if we go to our network or our model and we access the layers, the layer number 0 is going to be this block, right? So it considers this as a custom layer that we've created, and this would be layer 1. So this is layer 0. So stacked autoencoder layers 0, and then the other one is number 1. Pretty simple, right? And if we output is this here, and input would be this one here, right? We can actually test that. So I think we can put this here. And all right, so let's keep executing. So we have executed that one. So we define this one, and this one, and then we get our output. In this block, we could actually, as I said, put the input, and we get that like input image size. We could also get the input of the second one, which is 30 digits, and then we can get the output of the second one, which should be that 20 by 28 image in batches. So again, we can leave this here as it was. The shape of the train is like 55,000, 20 by 28, and then the summary, here is a bit. I don't like this that much because, I mean, it helps abstracting, but we don't really see the model. So we see that this one takes an input shape of 30, this one output shape of 30 digits, right? And this one of 20 by 28, but we don't see anything in between. Here we train, so we can, this is not going to take a long time. So we're training with the, and this was counterintuitive to me the first time I saw it, right? The input and the output are the same thing. And this is what I showed before, right? That we wanted the image of the landscape, the sun and the trees to be the input, but also get the same image at the other end. And then we also get the same validation data in the input and the output. So after these trains, right, this would be like maybe 10 or 20 more seconds, we'll have a trained model. Here we have a helper function to show the reconstructed images, and we'll run this to run right after epoch 10 finishes, which is going to be in 3, 2, 1, go. Right, so we're going to go through the model. We're going to get 3 images from the validation data set, and we're going to try to predict, which means we're going to input the image, and then we'll get the codings, and then we'll get the output out the other end. This is a bit weird because we're inputting an image and we want it reconstructed, which is it means that we have the original image and maybe we want to reduce noise because the image might be noisy, but or they might be I don't know, it's like a reconstruction, right? And the images don't really need to be there in the training set, right? These images are not in the training set. These are on the validation set, and you can see how they fit and then they get on the other end. So the ones on the top are the inputs and the ones on the bottom are the outputs. And what was interesting to me that I didn't get to do yet is that we could get codings, so just the digits on the middle, and change them, randomly generate 30 digits and then input them in the network and then see what we generate, right? That's something that I really want to do, and I have to do, I don't know, maybe next week. I don't think I have time now. And what we're doing here is that I'm printing the output of the autoencoder, right? I'm predicting here with the autoencoder only, so predict XY valid, and it's giving me 30 digits, and then we're plotting stacked autoencoder predict. Oh yeah, we're predicting with a given image, and then I'm printing the weights of the layer. So this wasn't really anything important because the weights are the same in both, because that's the weights on the layer after training, so on that specific layer after training. And here we can see that we get the summary of the autoencoder, but we also get the name of a layer and the output of a layer, right? We can see it here. And in here we define a feature extractor. That means that we define a new model that has the inputs of the stacked autoencoder inputs, and then the outputs of the stacked autoencoder output of the first layer. And if I run this, I think that should be okay. So that's what I was trying here, but I couldn't get. And what I did is that I defined the entire network again. So I define it again with the encoder and the decoder here. So on the summary, we can see the full network, not just two sequential layers. We train really quickly. We're not going to train for the entire time. And then we define a feature extractor. So we're going to get the inputs and then the outputs. And the inputs are the original input. So it's a 28 by 28 pixel image. And the output is from layer index 2, its output, right? That is actually the output of this network. So we're actually, with the train network, we're getting now a new subnetwork that if we give it an input, it's going to give us the result of this layer, not the image at the end, but the result of this layer here, right? So we go here and we actually get, for the two first images, we get the codings. So these are those 30 number digits that I was mentioning before. And if we get the summary, right, we can see that we have that input layer and we have that output layer. We have the, if we were to get the second stacked autoencoder that we have here, so let me add a code cell. Let me see how we can do. Okay, I add a code cell here and I print a summary of the entire network. We get, you see that there is this part here, top, that is this part here, right? So here we have 81,000 parameters. Here we have 163, like double thousand. And the part that I couldn't get to is that I wanted a subnetwork that will get an input in here and then put an output in here, right? To make this network work in here, I had to remove the part here that defines the input shape. And I'm not sure, maybe I can do that now. I'm not sure if I'll be able to, but I don't think I can specify that, right? Input shape 30, is that it? I don't think that's gonna work. Okay, let's just try it. But it works, but I'm not sure if we're gonna be able to do it. Right, so we're training. And we get the summary. Okay, now this one here. Yeah, okay. Model inputs must come from Keras input, thus holding past layer metadata. They cannot be the output of a prior known input layer. Here, a tensor specified as input to model 3 was not an input tensor, it was generated by layer 30 unit dense. Note that input tensors are instantiated via tensor Keras in blah blah blah. Tensor cause the issue was. Yeah. So here what I would say we could have done, so let me just try this. I'm sure how this is gonna work. And maybe, you know, maybe just to leave the code for live 33. So we're gonna make a copy and we're gonna call this live 34. All right, so we have here a new date, and that would be part 2. Part 1 and part 2. Okay, and before we forget, so that's saved. We're going to make this public so anyone can execute. Change to anyone with the link, copy link, and onto Discord it goes. All right, so that's there on Discord. This is a new notebook, so we're gonna have to re-execute some of the cells. Manage sessions, so we're gonna terminate the other one. Cool. All right, so let's. And I'm just gonna execute these two because we're gonna go straight. You know, these we don't need this definition here. So I'm gonna go to the where do I go? Maybe this we need. All right, so we define this here, so we're gonna train this and we're gonna try that we have our feature extractor. And now what I'm gonna do is, so let's put it here, new from live 34, that's today. All right, so so we want a decoder, and we're gonna get the input shape to be 30. We actually left that on the other notebook. That is not something that I should have done. Hi Majur, nice to see you. I'll also point to Majur Mysteries YouTube channel. So let me just pull that here. I don't know where it is. So architecture engineering. Right, we can actually go to Discord as well. And if you go to the share channel, Major is sharing a lot of his content here. So I'm gonna go and open. So I'm gonna copy Major's channel URL into the chat. Major's channel. All right, thanks for popping in. I'll put that there. There you go. Cool. And where were we? So here, what we want to do is we have a decoder model. So I'm going to try with the same settings we have. This works, but now we don't want the X train here. We want the codings. So if I go here and put here X train, well, let's do shape. So we have 5,000, no, not that one. So 28 by 28 images, right? But if we predict with that, so if we do feature extractor encoder, decoder to encoder and non-trained decoder. I don't think we got to do this, right? Okay, let's just do it. So we'll do codings would be X train. So let's see codings shape. Let's just try that. Okay, so we get 30 digits, 55,030 digits, right? So that's what we're obtaining here. And maybe we can try to visualize a few of those. So these are digits, and so let's say we get just one, right? We get just one of those codings, and this is a 1D array. Plot image. Can I plot this image? I'm not sure. How was this? I have a video on this and I forgot. So all right, so let's see. We have that numpy. Okay, we get an array. I don't remember right now. I think let me just see. So would I be able to do this? Hi, John Mark. Nice to see you around. It's been a while. I didn't live stream last week, and yeah, it's good to see you around. How's everything? So let's see. This doesn't work. Okay, so Keras display image. Okay. Let me see. Rank 3. All right, so this is what, this is kind of like the hack. Rank 3. Array to image. D-type, scale. Keras, black and white to color image. So, John Mark, which website do you mean? All right, so here I'm getting into a sort of a rabbit hole. So grayscale, RGB, so grayscale to RGB. All right, this is what I'm looking, just helper methods because I don't. All right. All right, so let's see. Maybe we just were missing this thing. Okay. Show. Okay. So let's see if this works as well. All right, so the image is there. It's really small, but it's there. Maybe we can do this plot image now. Plot, where is plot image? Plot image, plot image, plot image. Yeah, so this is really simple. I don't think we should just use that method, but well, let's try it. Okay. All right. So this works. So all right, so yeah, so with this, what I'm doing is, I have 3 digits, which is 0, 2, 5, 5, and 125, and I'm visualizing them as color, right? Like 0 goes to white. Well, this is weird because it's inverting the colors, but yeah, I don't know. All right, so I think so, yeah. So print image, let's see. Let's see what this is doing. All right, so this is actually 0. Okay, cool. All right, so we have a way to render that. So let's now render those digits. Let me see what we have to do that. So, well, we have a notebook that is for that purpose. So if I have here tf expand dims and I get this axis 0, what happens? All right, so we put that there, right? Expand dims, and dims axis 0. All right, so if we do this, yeah, no, it's good. It's good, yeah, Mark. It's just like I was kind of a bit confused there, but yeah, it's really inspiring. Actually, I have to say that's a big influence, and it's really. I mean, I love that. That's that my mom is an artist. All right, so this way I can do MPA array now, and we get there. All right, so now we have that, and cool. All right, so, and okay, for those of you, John Mark is referring to this page here. So I think I don't know if that's online or not, but oh wow, so we removed the profile picture actually. Huh. I mean, that makes a lot more sense. This is her. Um, yeah. So that's her. But it's interesting because I thought we still had the profile picture there. So yeah, there is a bunch. I mean, I've done this website as well, but as on my website, there are a bunch of writings and posts and sketches. So any of this, if you open them, there is like a sketch and an essay. This is almost all in Spanish. And you can also go to the projects. We have the main ones are the projects of portraits and sketches. So you have all these sketches. And we have the portraits. And yeah, that's me. I think, where was this? Faces, maybe? Portraits. Yeah, so I did this one here, which, I mean, it was meant to be that all the faces go at the same time, but they seem to like go however they want. Each one is a GIF, and sometimes they desynchronize. This is done with machine learning with Runway ML, and my face, my face is always in there on my site, but in this case, it's animated as well. And this animated one is me. This is not with machine learning. This is just like a video converted to GIF. But everything else is animated with I forgot the name of the algorithm now. Let's see. Yeah, with the first order motion model. So that's the one I used inside of Runway to do this. And it gets the motion from my face on the left from those frames, and applies it to the images on the right, which is, I think it's fascinating that this works. And I was able to do this with almost no effort. It was just more batch processing these things and putting them together more than actually having to do a lot of machine learning. But yeah, so these are here. Each of them is an individual GIF. So this is my mom, this is me, and this is Jose Luis, which we talked about a bit earlier. All right, so that's at nono.ma/portraits. You can go visit that. That's live. And yeah, let's keep going. Thanks, John Mark, for bringing that up. And where I was is that now with this function here, so we can get any array. So we can say, okay, let's say digits, right? So we get these digits and we put them here. We make an array of them. So let's say we put here all of these ones. And we go here, and so we go from digits to like a tensor, and then from that tensor or array, well, this is actually also like an array to an image, right? So here, right, we have a gradient from white to black, and this is because this should be the other way around actually. I'm not sure if I can do this. Nah. All right. well, doesn't really matter, but well, let's get to do it. I prefer to see the images as they are. All right, so image invert. Okay, so that's there. Pale is not defined. Image ops. Cool. All right, so now, now I'm happy because, we get here, we can say, okay, this is, let's say with zeros and one, right? So if we were to do zeros and one, we'll get black, white, black, black, white, black, right? So that's what we get here. If we use 255s, right, that we can now make like a gradient or something. So it's like black, white, gray, black, white, black, right? And if we want to do a gradient, of course, we just do a gradient, right? So here we get a gradient. All right, so why am I doing this? This is because in here we've gone from a series of digits to a plotted image, and we're going to make a helper function. So we're going to do here plot, so def plot digits, and we'll input a set of digits, and then we'll maybe just digits to image, and we'll just do this and just put this thing here, and we'll just return, well, let's do it here. And I never know if I should just return here or if it's better to know what this variable is and then return it. So here we have these digits, so we do our image would be digits to image, and then we have the digits, and then we just plot the image, and we should see the same. Great. So if I now we could make like another that is like plot digits, and then we just do plot image, digits to image, digits, and here we should just do plot digits, and that's it. Okay, can we run this multiple times? Not great. Cool. Okay, so what we're gonna do now that we have the helper method there, we had some codings, so we have some codings here, right? So if we get now a cell and say, okay, codings, what is codings 1, right? We have this. Can we 0, right? Yeah, so can we do this? So can we plot these digits? Yeah, okay. So these codings belong to an image, right? So we can say, okay, I have so codings would be, for instance, okay, so an image, right? So we can say an image is x train, and we get the first one, right? So we say plot image, image. Oh, plot image, image. Right, so that's our boot, right? And for this same image, we can say image codings would be, and we now get our feature extractor encoder. We get our image in, right? You see, well, this is the actual image, but we want it as a batch. So we're getting image as batch, and then we get here image, well, let's just do here image as batch, and then we get the actual image. So we can input here this image as batch, and we print the image codings, and let's see what they are. All right, so we run this one and this one. So we have a TF tensor, and again, so we need to do the number 0. So we print the numbers, and then we do the image codings 0. All right, so this image is encoded right now by our network like this. It's not going to work perfectly because we have trained only for 2 epochs. It's taking us some time to get here. And you can test now that if we do this, right? So if we get now a shirt, now the codings, so I'm going to save this just so you trust me on this one. So let's see if I can just put it here. I do that, and then the codings are different. So this is our shirt, this is our boot, and that's, you know, right now I don't know what it means, but these are 2 different representations or 2 codings that belong to different images. And if we were to fit them into the decoder, I will get from, you know, from here we go to here, and then from there we go to that image that we saw before, right? So from here we'll go to here. So here, then to the codings, then to this image. And I'm trying to understand how we can train now a decoder model. So we have this here, we'll get 30 digits as inputs, we will combine the decoder model, and then we will feed it. So we have now our codings, which are those that we had before. So we know that for our codings, so we're going to call them X-train codings. That might be more appealing. Oops. All right, so we have that. We run these things, and now note how I'm inputting those codings, and then I'm outputting X-train. So let's see what happened here. But receive input with shape, input 0 of layer, sequential 1 is incompatible with the layer, blah, blah, but have value 3, receive with input none. Input 0 of layer 1. Let's see. So what is the input? So that's okay, flatten. Okay, let me see if I can do here TF Keras layers input shape 30. Let's see if this works. Is right to input shape or a tensor, a type spec argument shape and include the batch dimension. Flatten. Shape. Okay, so it's shape, not input shape. Okay, so input shape. I think what I'm doing is exactly the same that this was doing, so maybe that just means that it doesn't work. So let's try it. So I could do directly there. Okay, this is not it. So here, so it would be something like this. But yeah, I don't think this is gonna work. To have value 30, input shade to have value 30, but receive input with shade non 20, 28. Okay, so fit X-train codings, X-train codings, X valid, no. let's try this. Yeah, that doesn't make sense, right? Okay, so shape 30, we get 100 activation cello. This is a good diagram. Mm, Decoder model summary. Well, this is, this is coming to an end. I don't think we're gonna get to solve this today, but let's see. So decoder model fit validation. So it's a bit weird. So what is the layer? So the sequential 5. Okay, sequential 5 is incompatible with layer. Expected access -1 of input shape to have value 30, but received input with shape none. Okay, so here, strain coding shape 30, but strain shape is 20 by 28. X none, but size Y none. Oh, okay, validation data. Okay, so validation data. Okay. So how did I miss that? I don't know. So we do here X valid codings equal feature structure encoder X valid, and then X valid codings shape. And okay, so this is print and this is print. Great, so that seems like now we might be onto something. So X valid codings. So hopefully that now runs. Oh, it doesn't. Okay. History, decoder, model, fit, X, train, X train codings, X train epochs 2. Let's comment this out. Okay. Hello, Lourdes. We were just talking about you. All right, so this works now. So it seems like the validation data is the one that is failing. So, I mean, at least let's see the decoder model predict. If we give it X valid codings and we get 1, right, we get something that seems like an image. So plot image reconstructed image. So we reconstructed image 0, maybe. Awesome. Okay, great. So we need to figure out how to add validation data without error. X valid. Great, but this is really cool. So this means now that if we got the the codings here, which is like plot, so plot digits, right? So maybe just get that. So these are the digits, and for those digits we're getting this image, right? So awesome. So let's now so let's add categories here. So reconstruct an image, right? So from digits. From digits. And now we're going to generate a synthetic image from random digits. Let's see what happens here, right? So we would, what would we do? So digits to image, right? Digits to image. Yeah, but now we need the actual, so if we print this, the shape of this, so shape, that's 130, right? So we actually have a tensor, so we can do a TF random uniform 30, I don't know, like 130, I don't know if that's how you do it. Yeah, so here we have what would be the input. Yeah, thanks, John Mark. Nice to see you around, and I'll see you next time. So the sound is a bit low. Is it me, or is it that I'm have the microphone really back? How is everyone else hearing me? Is the sound better now? Is it better, or is it that I'm just talking really low? All right, so let's take a look at the shape of these inputs. So we had some inputs here. It's actually a tensor with the same shape, I think. So 130, and then here we're generating 130. That's awesome. So we can generate a random image. So these are our digits or codings, random digits, and now we reconstruct the image, right? So we plot digits, random digits 0, right? So we have that there. Trying to expand them with 0. Let's see. Okay, so okay, so okay, let's try plot digits. Oh, okay, so I see. Okay, so let's do this. Okay, now this works. Okay, so these are random digits, and then that's an image. Okay, so this is pretty cool. So we're generating random images. Okay, so I guess we could make a GIF, something representative of this. So I'm wondering how I could do this. So if I could just save manually, which is going to be a bit annoying. Desktop, and so this would be coding 01. Probably this is something that we would need to automate. Don't want to do that right now. This would be synthetic 01, and now we'll generate another random and another one here. So this is coding 02, and then this is synthetic 02. And you know, I think this is going to be cool if we modify the images, add contrast, or do other things in a more controlled way. I think it's going to be cool, the effect that we're going to get. Synthetic 03, and let's do one more. So this is codings 04. Not sure what's going on. All right, so we'll leave it at 3, but you know, in those small images, you can see like the activated parts that are more common probably for like the random activations. And what I wanted to do was something like, so let's go to the desktop and maybe make a bash script. So it's gonna be a GIF, so montage and then a GIF. So boom, 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 boom. All right, so that would be 01, 02, 03, and for each of them we're going to do something like montage, tile, 1 by 0 by 1 by 0. Geometry is going to be 250. No, this is like small. Well, 256 by 256. And we're gonna have here codings 01, PNG, and then synthetic 01 PNG. So that'll be it. And then this is 0 and this is 3. Not sure how this would look, but let's just try it. Oh, I don't have a backup, so yeah, this is not great. Cool. Okay, we gotta do it again. All right, so let's see. Okay, so we got one here. I mean, not that this is gonna make any difference, but at least that is, you know, that we have real results. So we replace the 1. We replace the 2 now. And then replace the 3. Right, with image magic, that is what I'm using here. You gotta be really careful, because if you don't put an image, an output image, right, name, then you will overwrite the original image that you provide last. In this case, was the synthetic. So now we have that. So now we have these images, which is a montage. And I'm not sure if I could do something like this for the codings to have like a lot less height. Probably not, but let's try it. Yeah, it doesn't seem like it worked. And you can see now that this has been, you know, has been resized, which probably we don't want. So yeah, maybe, just maybe, we can leave this as it was, and make these ones 28 by 28 won't fit the 30 digits, so maybe 56 by 56. All right, we got it. So we got these things, and each of these ones is a coding. Now this is a bit weird because we don't, well, I actually prefer removing some information from the codings, but leave the other images as they are. So you see, this is the actually, these are the actually hard to see. So each of these images contains the codings at the top and then the image that we generated for each of them. Okay, that's good. So with this, we could make a GIF. So we could make like a GIF here. Okay, and this is our animation. So this is what we've done. For each of the encodings at the top, you get an output at the bottom, right? And I don't know, they're not great, but that is in some way what we get. This way you can, we could even generate a random. So this is random digits. We could, let's say, generate a synthetic image from cherry picked digits. And that way we could tweak what we have. So instead of doing random digits where we have a uniform, we could do a series of digits. So df convert to tensor, and we could have here, like now a list of numbers. So for example, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. Well, let's do actually just zeros and one. Well, so we have here 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we'll do 10, 10, and 10. And maybe we'll just do make these ones 1. All right, so digits tensor. All right, so that's our tensor. So we see the shape, it's 130. And now we can reconstruct the model. So we can plot digits, and then we get the digits tensor, right? And then we reconstruct our image with the digits tensor. Right, so that's our image. And let's actually, how can I do this? It would be good that these things auto save. But right now, I would say I'm not gonna do that. So let's just say I don't want to do that right now. So can I drag and drop here maybe? All right, so we're gonna make a weird way of making an animation, but I think it's gonna work. So we have this image here, and let's just make slight modifications to this, and you're gonna see what the encodings mean. Well, we're recording also, so that's making an animation automatically. And also, I don't know how much this is going to be changing. We'll see, because we need to see also the threshold of values in the original images, right? Okay, yeah, so this already works. Let's keep going. Maybe we can be a bit more radical here, changing faster. And hopefully you're kind of guessing what I'm doing right now. All right, so we're transitioning between different input codings. Okay, that was a bit fast. I don't know how that happened. Let me just take one more step. So, you know, this would make sense to be automated, but what I wanted to show you now is that these two are the same. I didn't regenerate. Okay. You see, so this is what I just wanted to do, and I think if we make it a GIF, it's gonna be better. So let me just make let's make a frames folder. So this is gonna be codings, test, and we have all this here. And we're gonna go to folder 34. We're gonna put everything in there. Stop. Frames, Keynote. Keynote, GIF. Frames. And now here we're gonna put our frames from there. So we're gonna save as we go. So we're gonna do this one, close, this one, close, this one, close. All right. And again, so we're gonna go to this folder, top, and I'm gonna make a GIF from the frames, and maybe we want it to be every 5. All right. Right, so this is a bit slow. But yeah, I guess like we get the effect that I was thinking of. This is a GIF and can really zoom out. Maybe a bit faster. All right. So this is where I wanted to get to, right? So if we go really small, hopefully you can see how this is like interpolating between different types of shirts and dresses, right? Like you can see that change in activation on the map. And yeah, so if you zoom in, you don't see anything, right? We're just like kind of merging and looking at different things. But what we've managed to do is to activate different parts of the encoder, of the decoder, when we go from codings and random codings that we're just like writing by hand into an output. And you know, one thing we're gonna continue with this because I'm really enjoying. So what's happening here is, or what's not happening is that we haven't trained for more than 2 epochs, either the encoder or the decoder. So the codings that we're using are not well generated, and the decoder doesn't work either. So we're gonna have to train for longer epochs to see the results, and we'll see that next week. So I'll kind of close up today's live stream with this, right? So this is like, I don't know where it is. It's like there with this GIF, or maybe there, this GIF that I'm happy that we've got here. So we have we've explained what stacked autoencoders are. We've seen what it means to encode an image into digits and then decode it. We've discussed why you might want to use these things. We've written or like gone through the code that we wrote last week with a stacked autoencoder, with an encoder and a decoder. We've used the feature extractor to create the codings and get those codings from the entire data set. And we've created a subnet with the decoder where we can input a coding of an image and then reconstruct that image. So generate synthetic images from new codings that don't come from existing images. So I'll open here. So if you have any last thoughts, any questions, any comments, if you want to say hi, feel free to drop those on the chat. I'm going to quickly, there's a few reminders here. which I'm not gonna do right now. And yeah, so I'll just add some reminders here while you think, if you have any comments or any questions. I'll remind you one more time to like the video if you want to support the channel and the work that I'm doing here with these videos, and to subscribe if you want to get notified when I upload new videos or when I go live next. It's my pleasure to have you online, to have you collaborate and be part of the community. And you can join the larger community at None of the Maslas Discord. We can wait to see what you share and what projects you're working on. And yeah, thanks a lot for watching once again. I'll see you next time. It's Nono Martinez Alonso here. I'll really encourage you to check out the Getting Simple podcast. It's at gettingsimple.com. It's a podcast that I do at least once a month. I release an episode. I try to release an interview monthly, but if not, every couple months. And yeah, we're trying to get up to speed to releasing also video and to release more material more often, because producing the material or like generating the content is not that hard as it might seem. What's really hard is the post-processing and getting it out the door and publishing online. I'll special thanks to Sajed for being there. Today we made him a moderator. He'll be kind of managing a bit the chat on YouTube. Thanks to Bea, Lourdes, John Mark, Mayur Mistry, Jose Luis, Namju, Ashkan, and really everyone who watched and everyone who's behind the Discord. So I know like also DBS is behind there, Alicia, Gerard, a lot of people. So yeah, join us on the community. You have also this QR code that you can read with your phone to go straight away to Discord. And this book is a really cool recommendation. If you use this link, there is like affiliate link. You can also support the channel that way. I'll encourage you to check out the publications and subscribe to the sketch.none.ma newsletter. I send a little story with facts, curiosities, or things that I've learned every Tuesday. I'll post the link. You can subscribe to my weekly thank you, Sajed, and everyone else. You can subscribe to my weekly sketches and stories newsletter at, and I'll put here sketch.nono.ma, and listen to the Getting Simple podcast at gettingsimple.com or wherever you get your podcasts. Yeah, so I'll leave that there. Thanks for everyone once again that connected offline, online, however you did. And yeah, this was Nono Martinez Alonso Live, and I'll hopefully see you next Thursday at the same time. That's like around 1 p.m. EST. Bye. Code a lot and share with us what you're working on. We'll be really interested on learning what you're doing. Bye.